Hi, I'm still working on this baseball game. I'm going through this baseball game step by step in the way that I teach different topics in class. Things may be a little bit out of order for how I do them. I might integrate more things or less things if I were doing this all at one time, but I'm not doing it all at one time. I'm doing it in the way that I do things in class. So that's going to show up in this particular case. So, you know, the last thing that I did, right, if I execute the code, was I modified this guy so after I press start I can pitch, and when I pitch the guy throws a ball, right? And he does the throw, but he doesn't actually throw the ball. So the next two things that I have to do are, one, sort of create the ball after he pitches, that's this time, and then next I'll have the ball travel uniformly in the x direction, in the negative x direction, towards the batter, who is not there yet. The batter will be there a little after I get done with that. And then after that, well, I'll do the thing where I make the batter, and I make the batter's controls, and the pitcher pitches randomly. And then after we've done that, and we can hit a line drive, then we'll start looking at more things about how to control the ball in 2 dimensions. So that's sort of the order. That's kind of the order that we do things in class. We do one-dimensional motion first, and then we do two-dimensional motion. So we'll do the one-dimensional motion as an approximation first in developing this game. So that's what we're going to do. We're pretty close to maybe, I don't know, 30–40% done. It's a good time to review. All right, so like I said, now I want to create a ball. Okay, and a ball is going to be just like the pitcher. It's a class. So we want an object, and to have an object we have to tell the computer how to deal with objects of that type. So I'm going to create one ball. I could create a lot of balls. You don't usually do that in baseball, but you could create a lot of balls that all act the same. Now we're going to make the initialization function method. And when you do that, you have to have these 2 underscores here. So you saw that I had 2 minus signs and then went back and gave them 2 underscores. I'll pretend like I did that on purpose. And when you have the initialization, you have to give it some parameters for what to initialize. You don't have to. You can initialize something blank and then use get and use set methods to set everything. That's a pretty good way to do things. But we'll just send it information about the ball. So some things that we need to know about the ball right away are the radius and the position. The other things that we're going to need to know about the ball eventually are the mass and the velocity, the initial velocity. So right now we're giving it the initial position, where it starts off, where it exists at the first instant it exists when the pitcher gets done with his throw, and how big to draw it, how big it is, right? And in fact, it's going to be a little bigger than it really is, because if you look at the animation, you'll see that there's a little red dot. I can't look at the animation right now. Okay. So now I can look at the animation. If you look at the animation, you see there's a little white dot there. That little white dot is a baseball that is about 1 foot in diameter. Okay, so it's a lot larger than a real baseball. But we have to do things to make things visible on the screen. So we'll just live with that. All right. Sometimes you have to live with things. So anyways, we want to create a ball that has a position and a radius, right? So the position is going to be at x position, self x, which is position sub 0. So when we send position, we're going to have to send a list of 2 positions, one for the x position and one for the y position. Those are going to be based on where the pitcher is, all right? And then we're going to want to create a property for its radius. So that's fairly simple. So that means that each time a new ball is made, each ball has each one of these things, each one of these variables inside of itself, and every method inside the ball class has access to those variables. Things outside don't have access directly, but inside it does have those. It does have access to those variables. All right, and the only thing we really want the ball to do right now is to draw it, right? And it will be drawn on a screen, and it will be drawn with some scale, and it will be drawn with some offset. And those are just things that we need to know about to draw it. The screen is where do we draw the ball. The scale is the scaling factor that goes from feet to pixels, okay? And we did that right away when we created the background. We created that scaling factor. And the offset is the number of pixels from the left-hand corner of the screen to the beginning of the upper left-hand corner of the field as it's drawn on the screen. All right, so those are just things we need to keep track of. All right. And eventually we're going to draw a circle. That means we do Pygame method draw.circle. And if you look at your documentation, that requires a screen, it requires a color. I will use white. I use gc.white because the game class has nice colors defined for us, so you don't need to know what white is. It's 255, 255, 255, but you don't need to know that. And then we need the position, which will be x, y, and the radius. And that'll give us a circle. All right. So we have to define each one of those things, x, y, and r. Okay. And these are going to be positions on the screen or have to do with pixels on the screen. We don't have half a pixel, so everything's going to have to be an integer. Right. So whatever we do, we take the integer part of that. Right, we're taking feet, which are floating point numbers, so self x is in feet, and then we're multiplying it by a scale. That scaling factor is also a floating point number, so that product is a floating point number. And a floating point number cannot be put into the draw functions, so you need to take that integer part of that, which just truncates the number at the decimal point and turns it into an integer, so that it has no decimal point ever again. And then we're going to add the offset, which is probably a integer already, but we don't really know, right? So we'll just make sure. And offset 0, remember that that indexing here, in brackets, that's an index. Indexing with 0 is when we have this pair of numbers for the x position, right? So we want to do the same thing. And I have this problem again. When I say scaling factor, I always write scaling rather than scale. And there we go. We've got the x and y, and we have to do something similar for the radius, only we don't have to worry about the offset for the radius, right? The radius is just a number in feet. It has nothing to do with the position on the screen, right? The position on the screen is the x and y. The radius is how big to draw around. If you don't believe me, you can look at some of my analytical methods videos, and then you will understand all. All right. So those are the things we need in our ball. Now we have to do things with the ball, right? So I've got this ball, but I don't have a ball. I have a class balls. I have to create a ball. The question is where do I create a ball and how do I keep track of it? I have to create the ball. I don't have to, but the best place to create the ball is in the picture itself. So when the pitcher is done, he can throw a ball, right? So basically what this is going to do is it's going to create a ball. So we say ball is equal to capital ball. And that is going to need a radius and a position, okay? So the radius I'm using is 0.5, so rad, and pause. So the radius is 0.5, and the position is going to be based on the position of the pitcher, and this is all going to be in feet, right? At this point, it's all in feet. So the pitcher is now the thing I'm doing this in, so I use his position, self.x, And then I have to figure out how far, when he's finished that throw, how far he's gone, right? So I can take a look at that frame 5 and try to figure things out. What I'm going to do is I'm just going to figure out where his head is, which is right at the top here. And the top of his head is at center 0 minus 1.0 times the height. So it's at his x minus his height, basically. So that makes for a good place to put it. So we're going to draw the ball just above his head. We're going to put the ball just above his head. So we go to his head, self x, and then we go minus self dot h, I think is his height. Yeah. So that other stuff was all done after conversions. Now we need to have this somewhere above his head. So self dot y is minus, so minus, I think, let's say 0.2 times self dot h. So it's a little bit above. So his head, the center of his head was about 10% down below the center line. Let's make this about 20% up. We'll see how that actually looks when we actually draw it. And now there's one more thing, is that we don't keep the ball in the pitcher. We have to return it. So now we return the ball. But, you know, where do we return the ball to? It's a good question. Where we return the ball to is the place where he throws, and probably the place where he throws is going to be this update, right? So we're going to have to return a ball from this guy. And usually he's not going to send any balls back. So we'll say the ball is usually equal to none. So there's no ball. And then let's say, well, self dot. Okay, so now we've changed the state. So now let's do something with the state. So if the state of the guy is equal to 4, let's say, then let's say the ball is equal to self.throw. Did I call it throw or throw ball? I'm going to go with throw ball and see what I said up here just a second ago. I did say throw ball. Okay, so I also want to modify this, refactor this just a little bit. So what I'm going to do is say if it's greater than or equal to 6, and modify down here the draw function so that it'll draw the same frame. Well, it will draw the same frame no matter what. So it will keep drawing frame 5, whether it's at frame 5 or frame 4. The only reason why I did that is that it'll only go to this frame 4 once, and at that point it'll throw the ball. Now the question is I'm returning the ball from the update. What do I call the update? Do I call the update from main? No, I don't call the update from main. I call the update from the engine. Okay, actually I'm just about done with this. So I'll go ahead and I'll stop and I'll add in, then I'll do another video on how to do the rest of it for the ball. So let me just make sure I don't have anything that's obviously wrong. And it does break. And in 65, what did I do in 65? Oh, I didn't create the pause. So pause is equal to pause x comma pause y. Okay, let's see if it does everything I want it to do. Yeah, it still looks fine. Okay, so everything seems to be fine. I've refactored the pitcher. I've created the ball class. Now I have to refactor some other functions. I have to refactor the engine and the view and main, and then everything will be okay. All right, so I'll see you in the next video. All right, see you soon. Bye now.